Welcome students. My name is KG Francis Minto, Assistant Professor from Department of Electronics, St. Xavier's College. The course title which I'll be doing is Microprocessor and Microcontrollers, and the unit number is 78051 Programming. The module name is 8051 Programming in C for time delay. The outline of the module is as follows: data types, 8051 Programming in C for time delay. Through this module, the students will be able to explain different data types in 8051, develop a C program for 8051 using different data types, and develop a C program for 8051 using delays. 8051 programming in C. Most of the compilers of R produces hex files that is downloaded into the ROM of a microcontroller. Now in this microcontroller, we have limited on-chip ROM. So if it is 8051 microcontroller, the on-chip ROM is 4 kilobytes. C programming is less time consuming, but it has a larger hex file compared to assembly language. But the reasons for writing the programs in C, it is easier and less time consuming to write the code. It is easier to modify and update the C code, and you can use the code available in the function libraries. Now, there are different data types present in 8051 microcontroller: unsigned character, signed character, unsigned integer, signed integer, single bit, and special function register. So the first one what we'll be covering is an unsigned character. This data type is the most natural choice for 8051, which is an 8-bit microcontroller. The unsigned character is an 8-bit data type, and the range is from 0 to 255. In terms of hexadecimal, it is 00 to FF. C compilers use the signed character as a default if we do not put the keyword as unsigned. Pay careful attention to the size of the data. Try to use unsigned char instead of using integer if possible, because we need to save the number of bytes. So over here we'll have a quick review. Write a C program to send the values of 00 to FF to port 1. So we need to include the register 51.h, which includes all the special function registers, a void main void, and I have used unsigned char I. So the value which can go is up to 0 to 255. So I have used a simple for loop for I is equal to 0, which is your initial condition, I less than equal to 255, I plus plus. So over here, port 1 will be always receiving the values of I. So over here, I will be 0, 1, 2, it will go up to 255. So this is a simple way of representing a value of 00 to FF on port number 1. So what if the value is in decimal, the value which will be displayed on port 1 will be in terms of hexadecimal. The next program is to send the hex values for hex key characters 0, 1, 2, 3, 4, 5, A, B, C, D to port number 1. Again, we have included a register 51.h, void main void, and I have used an unsigned character to initialize a array. So 0, 1, 2, 3, this entire thing is as my string, it's like an array, and I've used another unsigned char for the loop, for loop. Since the number of elements are 10, I have used a for loop for 10. So P1, that means I want to send this array one by one to a particular port. So P1 is equal to my num square bracket of I. So first thing it will show the value of 0, then it will send the value of 1, then it will send the value of 2, 3, 4, 5, A, B, C, D. So in this way, you can send the values of 0 to D in the form of a string to any of the port. So we've used the unsigned char. The next one is to toggle all bits of port 1 continuously. So over here, we have written a for loop which is in the continuous loop. It's a continuous while loop. So instead of writing while 1, open, close, you can say as for, semicolon, semicolon. So this is called as an infinite loop. So what we do is we put port 1 is equal to 0x55, and next instruction will be port 1 is equal to 0xa. So this is called as toggling. So port 1 will keep on toggling between 55 and AA. The next one is data types, which is signed character. The signed character is an 8-bit data type and we use the MSB. So D7 is used to represent whether the number is negative or whether the number is positive. So you can go up to minus 128 to 127 values. We can't go beyond plus 21 to 8. So we should stick with unsigned character unless the data needs to be represented as signed numbers. So please do not use signed character. If you are trying to stick with positive numbers, use unsigned character. So now an example is shown to you how to write a program to send values of minus 4 to plus 4 to port 1. So over here, plus 1, minus 1, plus 2, minus 2, plus 3, minus 3, plus 4, minus 4 are the values which is required to be displayed on port 1. So over here, again I have used a loop over here. For I is equal to 0, I less than equal to 8, I plus plus. And I have used the unsigned char. The reason why I have used an unsigned char is because it is a positive number. But over here, I have just used a normal char. So normal char will be a signed char. So in this way, the numbers of plus 1 to minus 4 will be displayed on port number 1. The next type is unsigned and signed integer. So unsigned integer is a 16-bit data type and the value can go up to, in terms of decimal, is 0 to 65,535, which is 4 zeros to FFFFH. This is used to set counter values of more than 256, or it can be used to define a value of 16-bit variable for memory addresses. If we use a signed integer as a 16-bit, the MSB, that is D15, will be used to represent whether number is negative or positive. And over here, we have 15 bits for the magnitude. So the maximum number which can be displayed is 32,767, and in terms of negative, it is minus 32,768. Now over here, the next part is the single bit. You need to use only a single bit of a particular port, and I want to toggle bit number D7 of port number 1 15,000 times. So if you want to use a S bit, you need to use S bit, and I've used as a defined function, make a function. My bit is equal to port number 1 bit number 7. So S bit keyword is used to allow access to the single bit of the special function register. So next thing is I've used unsigned integer I. I'm using unsigned integer I because I'm using only positive numbers. For I is equal to 0, I less than equal to 50,000. If I do not use unsigned, if I could just use integer, the maximum number would have been 32767. So I want to use number up to 65,000, and that's the reason I've used unsigned integer. So in the loop, I will make the my bit is equal to 0 and my bit is equal to 1. So indirectly, port number 1, bit number 7 will keep on changing from 0 to 1. So it will keep on toggling between 0 and 1. The next one is with regards to bit. You can use bit data type to access single bits of the addressable memory spaces between 20 to 2F each. To access the byte size special function registers, we use special function register data type. So over here, a quick summary of the data types is mentioned. In unsigned character, it's an 8-bit disk which can go up to 0 to 255. In signed character, again it is an 8-bit which can go up to minus 128 to 127. In unsigned integer, it is a 16-bit which goes from 0 to 65,535. And in signed integer, it is a 16-bit which is minus 3 to 768 to 3 to 767. S bit is a single bit, we can use a bit addressable only. And if you want to store information in the form of a bit, it is bit as a command is bit, and this is for port, and it is RAM bit addressable only. And if you want to use RAM addresses which is from A to FF, you have to use SFR, which is a 8-bit. So now the next part is how to use as a time delay. There are two ways to create a time delay in 8051C. One is using a 8051 timer by using it is a special function register, and the other one is using a simple for loop. There are three factors that can affect the accuracy of a delay. The first one is your 8051 design. It depends on the number of machine cycles and it depends on the number of clock periods per machine cycle in order to execute any instruction. The second one is the crystal oscillator, which is connected between X1 and X2 input pins. It is the point where the crystal oscillator has been connected. And the third one is because of the compiler choice. C compiler converts the C statements and functions to assembly language instructions. Different compilers produces different codes. Now in the next example, we need to write a C program to toggle the bits of port 1 continuously forever with some delay. So we have written a program hash include register 51.h, which is used to include the register file of 8051 microcontroller, void main void unsigned integer x for. Now for loop is written as 2 semicolon, which means it is a repeat forever. Open the bracket, port 1 is equal to 0x55 for a particular delay which is unknown. So this particular loop will be repeated 40,000 times. After repeating 40,000 times, then it will make the port 1 is equal to 0xAA, and again it will be the loop for 40,000 times. So you need to use an oscilloscope to measure the exact duration, because this is a software delay. We do not know exactly what is the delay produced by 40,000. So the next one is to write a C program to toggle the bits of port 1 continuously with 250 milliseconds. Now over here we have included a register 51.h and then we have included a function subroutine named as ms delay. So what is this? This entire subroutine is used to produce the delay in terms of milliseconds. So this is already been tried and tested, which gives you a delay of 1 millisecond. So if you call your 1, it will give you a 1 millisecond delay, and if you call this as 250, it will give you a 250 milliseconds delay. So port 1 is equal to 0x55 ms delay. You're sending a parameter called as 250, and this loop will be executed 250 times. So the total delay will be 250 milliseconds to be precise. Then the value of port 1 will be equal to 0xAA, and again you will be calling a delay for 250 milliseconds delay. So port 1 will be continuously toggling for 250 milliseconds delay, and this delay can be checked by using a oscilloscope to find out the delay of on time and off time. With this, we come to the end of our module, and these are my references. Thank you.